Okay, now I have finished the fiber optic link that we did. Let me get it untied here so you can see it. Remember, when you're handling these, you want to be extremely gentle because, again, you don't want to apply any back pressure to the connectors, to the fiber going into the backs of the connectors. But we've got our completed fiber link here, okay? Now we need to test this, and to test this, the only industry accepted tester is the optical loss test set, and that's what we're going to use here in just a minute, okay? So I'm going to set this aside for a moment while I show you how to set up the tester, okay? This is an ideal FiberMaster tester. It is a two-part tester. It comes packaged like this with this end is in here. You pull this out. This is the light source. There you go. This is the light source of the tester. Now, one of the really attractive things about the ideal FiberMaster tester is it can test 62.5 and 50 micron multi-mode. It can test single mode fiber as well because it has the 850, the 1300, the 1310, and the 1550 light sources built into it. This is a very positive feature. Now, it also comes with various adapters, and what I've got screwed into the top here, now this side is going to be where the LED wavelengths will come out, the 850 and the 1300. This side will be where the laser lights come out, the 1310 and the 1550. I have screwed on the SC, Sam Charlie connector, adapter here, and I have inserted a Sam Charlie connector. Now, notice that the cable is blue, okay, that's coming out of my jumper. If you're testing 50 micron fiber, you need 50 micron jumpers. If you're testing 62.5 micron fiber, you need 62.5 micron jumpers. If you're testing single mode fiber, you need single mode jumpers. That's the way it is. So, I have my jumper here. Get this untangled. I've got my jumper here, and this is what the other end looks like. The other end is a Larry Charlie connector, okay? And it's going to go into this, what we call a barrel or adapter, and it's going to click in. Now, to zero my meter, and this is my meter side here, to zero my meter side, first I'm going to turn on my light source. Now, my light source is turned on to 850 nanometers. Good enough. And now I'm going to take the meter side here, and so that you can see this, I'm going to connect. This one has a screw-in Frank Charlie FC connector, which is kind of old school, but it's good because it screws in and stays locked in place, doesn't move. And it should say null on it because it's not, right now it's not hooked up to anything, right? So it says null. So now I'm going to plug this into the adapter, which has the light source connected to it. And I'm reading it. I will change this so that you can see what it's doing. I'm reading roughly -6 dBm. That's decibels reference to 1 milliwatt. In fiber optics, the light power is measured in dBm. And if it's negative, it's an LED. If it's positive, it's a laser. This is negative. Now, one of the nice features about this particular meter is it has this button here where we can zero out. This is funny because I'm doing this while I'm watching it. I can zero out my meter as I just did here. So now what I've effectively done is I've taken this part of the equation, the two jumper cables, the jumper from the light source and the jumper from the meter and the barrel, and I have effectively zeroed them out on the meter. So now I can connect my fiber that I want to test, and I will get the test results should be accurate. So from here, we look at we're going to have to add to the equation here. We're going to add our fiber jumper, and we're going to have to add another barrel to make it work. So let me just point out to you that per the industry standards, what I'm holding in my hand, well, okay, the dust cap is your friend. Just remember to take them off. I don't know what that was, but we'll get to it later. Okay, so we take our dust caps off. Now, what I'm holding in my hand right here, this combination of connector, barrel, and connector, call it an adapter. They kind of started getting called barrels because they used to all be round ST types. Connector, adapter, connector. This, what I've got in my hand here, this can have a maximum of 3/4 of a dB of loss. Doesn't matter if it's single mode, multi-mode, doesn't matter if it is 50 micron or 62.5 micron. This is the industry standard. Now, let me just point out that there's a couple of standards we're working with here. One is the industry standards. If you're a structured cabling installation company and you're doing fiber work, particularly single mode fiber work, they're not going to accept a set of connectors that has 3/4 of a dB of loss. What this means is that the end user, specifying engineer, people like that, they could specify and say, we want a tighter, we want half a dB loss, we want 4/10 of a dB loss, whatever, for a connector set. And if you're the contractor, you have to meet those specifications. But the industry standard, the EIA TIA standard, is 3/4 of a dB of loss for what I'm holding here, regardless of the type of fiber. Now, what I'm going to do here is, here's what I wanted to point out to you. Let's say we test these connectors and they've got 1 dB of loss. Well, if our goal is to connect up a set of media converters, Ethernet media converters, that'll go to 12 dB of loss, and our connectors have 1 dB of loss, you know what? It's no big deal. It'll still work. Everything will be fine. Now, if I test these connectors and the connectors have 7 dB of loss or 20 dB of loss, well, no, they're no good. One of them's a problem, and you'd have to try to figure out which one it is. And because of the dark color of this jacket, a laser light will not go through it. Therefore, you're basically going to have to cut both ends off and start over. That's bad. So you want to do this stuff carefully the way I showed you initially. Now, I've got the Scotch tape out here because when I hook these up, I want to make sure they're clean. Okay. So here's what I'm going to do. I'm going to take one end of this here, and I'm going to connect it. I'm going to clean it, tip it on the tape, and I'm going to connect it to the barrel that is coming, or the adapter that's coming out of the power meter. So it goes in this side. Then I'm going to take the other side here, and I'm going to connect up the connector that comes from the light source, like that. So I've connected both of them. And now, if we look at our meter, we will see that these two, this fiber optic link we built, has a loss of 0.3 or 3/10 of a dB. Should say 3/10. Yeah, 3.5, 3/10. 3/10 of a dB. Okay. Now, let me just show you that if you start to bend the fiber, and it's hard for me to see what I'm doing because I'm trying to show you, but here, like, let me put a bend into the fiber, and you see now I can make that dB loss number jump way, way up. Okay, because I'm bending the fiber. You see how I've got the fiber bent right here. Okay, but when I straighten it back out, we should go back to 3/10 of a dB, and that's what we did. The fiber is very strong when it's under the jacket and under the Kevlar and everything else. It's when the fiber is stripped of its outer components and its protective materials, that's when it becomes vulnerable. So, here's the question. Is this connector set that I built here, does this meet industry standards? Absolutely. If you're actually doing testing in the real world where the fibers are 1,500 feet long, it's a two-person process. You've got one person on one end who's plugging in the light source, and you have the person on the other end who's reading the power meter. Okay, so that's the way that that's done. And let me just point out that in the world of formal fiber certification, where you're working for a structured cable company and you're certifying the fiber to be good, you actually perform 6 tests. You do 3 tests one way, you do 3 tests the other way. Let me get my hand so I can see where it's going there. You swap ends with the light source and the power meter. You swap the ends so that you get 3 tests going one way, 3 tests the other way. They all have to be within 1/10, and they all have to be within industry standards. And if it passes that way, then you know, and you can write down and you can show it to the customer and say, hey, I tested them, buddy. They're really good.